Okay. So good morning once again, no? So this is CS1130 for the BSIT freshman class, no? You must have come from different schools, I presume, because many of you are from out of town, out of the city. So anyway, we'll get to know each other as we go along. This is CS1130. This is an introductory course requirement for all freshmen, no, in the CS department. Those who are taking BSIT, BSCS, and BS Data Science, the most recent offering, BSDS. Okay, this is a requirement to everyone, no, who will be part of the CS division, Computer Studies division, no, of Ateneo de Davao. So anyway, welcome everyone. No? Uh, I'd like to know if you have logged in, all of you have logged into our regular class. Who hasn't logged in yet? Okay, you chat me or you raise your hand. So I presume you have logged into our regular class. We have our syllabus there. This is the standard syllabus used by the CS department in the previous courses. This syllabus was created before the pandemic. So anyway, I'm still going to update this, no, because there are recent additions to our syllabus. The course topic which we will follow, the sequence of topics which we will follow will be the one in regular. So the topics there will serve as our course outline. Okay? Any questions so far? Okay. So ito yung ating formal course outline. So if you look at that, now this is an introductory course to all freshmen. Not necessarily, no? Some of you are non-freshmen, no? Those who have came in late, transferees, no? Most of you are freshmen. No? So what is this course all about? This is an introduction to computing. What is computing? Computing is a technology based on electronic devices that are used to process data, not necessarily computers. No, it includes cell phones, no, calculators, tablets, no, those with operating systems. Okay, they follow mostly devices with operating systems. That's what electronic computing is. So, in a nutshell, no, this is a sneak preview of all the courses that you will take up during your 4 years, no, in the computer studies division. So this has topics in, okay, binary arithmetic, no, binary numbers, okay, and this has top which is used in computers, no, and then you have hardware topics starting with boolean and logic gates. Okay, so dito boolean design. For each of these topics, you will have a course later. You will take up a course later. No? For example, for binary numbers and boolean logic, the computer science majors will take up digital design. I'm not sure with the IT, no, but the CS students will take digital design. This will be your introductory topic to that whole semester course. And then we will also have computer hardware, components of a computer system. Now, this set of topics is an introduction for you, for all of you, because you will have a computer organization course. No, the CS students will have computer architecture, and the IT students will have computer organization. You will have one whole semester of this, no? Computer hardware. Do you follow? Maybe I think it's in the third year. Yung ano, yung I think also, no, digital design will also be in the third year. No? So storage, input and output devices, and then we will have programming. No, uh, the CS students are taking programming, introduction to programming also concurrently. Do you have a programming course this semester, IT students? Are you taking programming this sem? I'm not sure about you. So yeah, so concurrently you will be taking programming, but we will be introducing it in this course formally. No? We will introduce the history, and then we will be writing programs, no? And as a platform, we will be using Visual Studio Code. Visual Studio Code is a text editor. Okay, you follow? There are add-ins, no, which you can integrate with the platform so that you can do HTML, no? You can do JavaScript and others. Okay, so we will be also having HTML, simple web development, simple tags, no? Like header tags, paragraph tags, no? Those who are taking science and technology strand during their senior high must have taken this, no? If you are not, you haven't taken this up yet, don't worry. We will take them up from scratch, no? So we will be developing simple web pages, and we will be writing JavaScript programs. As a platform, we will be using Visual Studio Code, and you will be launching, no? For me to check your web pages and your visual, rather your JavaScript codes, we will launch them in the net, no? There are several platforms, no? But in this case, in our case, I will introduce you to W3 School Spaces. Okay, there are many others, no? The good thing about W3 School Spaces is it is a learning system. It's an online learning uh, website which has all the materials in it in order for you to study different fields, so in programming, including HTML, JavaScript, C Sharp, C++, and so on and so forth. SQL, no? It's there. And at the same time, right there and then, it will allow you to launch your sample code in their website so that you can view the website in the net. Okay? So we'll be using W3 School Spaces. I'll show you how to create. You can, if you want, you can create your free account there already. We have a free account limited to a size, no, a certain size, and you will have a free domain, okay, which you can use, no, so that it will become your standard URL every time I check your assignments. Okay, so we'll be studying JavaScript, no, as our programming language. We'll be introducing data types, how to declare variables. Some of them will be taken from Tutorial Republic. Tutorial Republic is a counterpart or a competitor of W3 schools. Okay, I'm not sure if they have a free website, no? So anyway, from time to time, we'll be using W3 schools and Tutorial Republic. So we'll be writing JavaScript functions and putting HTML tags. So we will write programs such as adding of two numbers, no, simple computations, no, and then we'll have a grade computation example, and then we'll have loops and counters, no, and arrays, and then we'll be discussing a certain type of a program called a factorial program, and then JavaScript arrays and objects, in which we will be discussing or showing a shopping cart, no, like a Lazada. Okay, we'll be writing a simple shopping cart website. Okay, I will show you the source code, no? And then you will have an assignment to write. So from time to time, there will be formative requirements, formative test requirements, no? So I'm sure you are introduced, no, during your orientation, that there will be formative assessments. So in short, there will be tests, online tests. The formative assessments will be used as a requirement. It will not be used for grading. Okay? Am I clear enough? The formative assessments are quizzes and tests which you will take online but will not be used for grading. But they will be used as a requirement for you to take the next, okay, formative assessment, which means you cannot take the second if you haven't passed the first. Now, at the end of the semester, you will be given a summative test, okay, which means it's an online test which will cover all topics, okay, which will become the basis of your grade. In this course, there will be two summative assessments. There will be a performance test, and there will be an online test. The performance test is an actual program which you will write in JavaScript, okay? And the online test is a quiz, no? Composing of about all topics, no? About 100 item test each you will take. Now, the performance test and the online test combined together will compose your final grade. Okay, am I clear, everyone? Am I clear? Are you still there?
Yes, sir.
Okay.
Yes, sir.
So am I clear now? So your final grade
Yes, sir.
will be taken from a performance test, which is a programming assignment, and an online test. Okay. So that's the only source of your grade. Now, sometime no, at the end of the semester, you will take the summative test. Okay. And then this by the way, this syllabus or course outline will be doing some upgrades. We'll be having some upgrades. I will be adding topics on computer networks and databases. Okay. So SQL, we will take up a little SQL, no? Because sometime in the future, all of you will take up, I think there will be 2 semesters, no? For both CS and IT majors, you will have 2 semesters of relational databases. Okay? Any questions so far? No? You'll have two semesters, and then you will have 1 semester of computer organization, and then you will have 2 or 3 semesters on web development. They follow the IT, I think, will have 3 semesters because they will have a basic, and then they will have web tech and web tech 2. The CS students, I think, will have advanced topics, no, in web development, and then they will have basic web development, and you will have uh, alternatives, no, alternative subjects, no, which may have something to do with web development, no. So we'll take up a significant portion that you need in order to be introduced properly to those courses, no. So when you finish this course, it's like the subject, it's like you have finished the 4 years, no? Do you follow? But only portions, not only the introduction part. Okay, this is your sneak preview of the 4 years that you will have in college, in case you intend to stay. No, of course, if you intend to stay for the remaining, no, finish the course. No, if you intend to finish this course, I hope so. No. So, any questions so far? Any questions, everyone?
Opo, sir.
Okay. So anyway, if you have no questions, then we will start formally. No? Uh, we have a book. We have an ebook now which you can download, but we will not be following the sequence of the ebook. Many topics were taken from the book. No? Anyway, no? We will be following strictly the sequence that we have in our regular class. So I recommend you take a look at this, at these videos. No? These are from very popular computing websites. No? Very short videos, no, but uh, full of content. Okay, full of content which you can use in our for appreciating the whole course. No? So we will start with history of computing. There's also a course for that. Why do we need to study history here? Anyone? This is a computing technology course, and what has it something to do with computing technology? Okay. Computing technology at the present is a very complex matter. Okay, it cannot be discussed in one whole semester. Now, the very difficult part is understanding the design of the different computing technologies. Like, for example, you want to understand the design of a CPU, the design of a programming language. No? Describe the architecture of the Core i3. That's very difficult. Now, why? Because it's already very complicated. One way to study the design, we need to study the design because we program them, right? In order to understand, to program them properly, we need to understand the design, the background of the design. Now, one way to understand the design is to study how it came to be or study its evolution. Like understanding the design of of a locomotive or of the modern ignition engine in an automobile, 'di ba? Ang hirap intindihin yan ngayon. But if you study the evolution of the car or the automobile, you will learn the components of the ignition and engine. Di follow? Mas madali siyang intindihin. So, it's much easier to understand the design of computers by studying how they came to be. Do you follow? Studying how they evolved. Okay, for example, if you're asked, who invented the automobile? Ford? Not necessarily, because there are many components of the automobile that are used by that were developed by other people. Now, the automobile is not a single invention. No, it is an evolution. It is a combination of the different uh, improvements during those days. Computers are also like that. We cannot pinpoint a particular inventor who fully invented the computer. We can only say who started all this. Okay? So who started? The main question is who started the design of the first computer? Who really invented the first computer, the machine which we can consider as a computer? Do you follow? So do you know the person who invented the first computer? First computer? It's not Bill Gates, no? It's not Steve Jobs or Mark Zuckerberg, no. Charles Babbage, no. Babbage is Babb, double B, no. That's right. Ramirez is correct. No? It's okay, no. I also make a mistake like that. But before we discuss the invention, let's discuss how it came to be. No? Now, the evolution of computing technology started during the early modern period. Now, when we talk about the modern period, we talk about the modern period in world history. World history tayo dito. This started during the 1600s. Bakit 1600s? Because the modern period should have started. The modern period is considered to be what do we consider the modern period? Those that had so many developments in technology, no, not just in electronic, but engineering, no, politics, science, no, medicine. Do you follow? So the modern period happened during the 1600s. What happened before it? Before it is considered the medieval period in Europe. Okay, the modern period should have started a long time ago during the birth of Christ, but it stopped. It started with the Roman Empire because it were the Romans who introduced different uh, improvements or developments in different aspects like sciences, engineering. No, they built cities, they built governments. No, ang Roman period. Now, the peak of the Roman periods was during the first century, which is the birth of Christ, no, 0, to 473 or 470s during the 5th century. The first Roman period died during the first century. So along with it died modernization. Pagkawala ng ano, Roman Empire, modernization also died. And Europe entered into a dark age, which means that from the 5th century to the 17th century, which is 1642, not much development happened. Walang nangyari, just wars between European countries, no, European tribes. Ang daming wars. But nothing happened in terms of computing technology and even in sciences, no, and medicine. Not much development. The early modern period was considered to be the period where technology started to develop. Do you follow? No? Technology in general, engineering, sciences, chemistry, mathematics, no, developed during the 17th century, 1642. One of the most notable inventions was done by Blaise Pascal in France, no? French. So modernization came in Europe, no? Started in Europe, particularly in countries like France, Germany, and England. No? France, Germany, and England. Ito yung mga roots. These are the roots of the modern period when technology started to sprout. Okay. During 1642, 2 years, no, Blaise Pascal invented a mechanical calculator that could do addition and subtraction. These are called Pascalines. No, let's look for Pascalines. How does a Pascaline look like? It's like this, no? So there are no keyboards like in a modern calculator. but the digits are indicated by rotating wheels. No? In a rotating wheel, there are 10 digits from 0 to 9. The first digit indicates the unit, and the next is the tens digit, hundreds digit. No? So addition and subtraction is done by turning wheels. If you'd like to add, you turn it counterclockwise by yes, counterclockwise. If you like to subtract, you turn a wheel clockwise. Okay, do you follow? Although this is similar to an abacus, no? The abacus is already there. It's a very ancient device which is used for addition and subtraction. Now, ang sa abacus, you just shift the beads from left to right in order to do addition and subtraction. And even multiplication can be done there. No? Do you follow? So dito, it's like an abacus, no? But instead of beads, it uses rotating wheels to signify decimal digits. So ito yung Pascaline. No? Simple addition and subtraction. Before that, addition and subtraction were done by hand. Okay? So walang ibang choice but done by hand. Later, no, in Germany, no, Gottfried von Leibniz, 1673, a few decades after Blaise Pascal invented the Pascaline. No, so this is an evolution, no? Si von Leibniz did not invent a unique machine, but he borrowed Pascal's ideas. Okay? He improved the Pascaline so that it can do multiplication by repeated addition. So by repeating addition, you can do multiplication. And by a process called shifting. By the way, the Pascaline is a decimal system. Okay? The step reckoner, which is an invention of von Leibniz, an improvement of the Pascaline, is a binary system. Now, using binary, you can do a multiplication by a process called shifting. Do you follow? Because Leibniz was a strong advocate of the binary system. What is a binary system? It is a numeric system, no, which represent numbers by zeros and ones, no. The base 2 system. So base 2, ang decimal kasi is base 10. You must have gone through that in grade school, no? The different base of numeric representation. You have base 2, base 8, you have decimal, which is base 10, you have 16, no, and so on and so forth. So the good thing about the binary system is it can do multiplication by shifting to the right. It can also even do division by shifting to the left. Do you follow? So yun yung improvement ni von Leibniz. You should be familiar with this, no? Because the computer started with binary systems. Okay? Any questions so far? No? Okay. So the next improvement, significant improvement, is in France, no? See, France again, France, Germany, and later, no, we'll have Great Britain, England, Great Britain, England and Scotland yung Great Britain, di ba? England, Scotland, and Ireland. Okay, and then in 1801, no, there was a mechanical invention that was used for weaving fabric designs. It's not used for computing. It's called the Jacquard's loom. Okay, Jacquard's loom. Okay? It was invented by Joseph Marie Jacquard from France in 1801. Later, no, people discovered that Jacquard's loom can also be used as a recording device. No? Not as a computer, but as a recording device to be used as input to a computer system. Do you follow? Kasi wala pang keyboard eh. Wala pa tayong keyboard, wala pang mouse. Do you follow? How do you make input? You use punch cards. Let's look at for a Jacquard's loom. Okay, remember, what is the use of a Jacquard's loom? It is used as an input device, no? Ordinarily, no, it was used as a design for fabric. Kasi pag gagawa ka ng tela, no, there are designs, print designs. And the weaving is done such that the threads are injected or are allowed to pass through the holes. The output of the holes will become the fabric itself with a designated design, okay, indicated in the punch cards. Ganito. Okay? Later, no, people discovered that this can be used as an input device to a computer, such that a particular sequence of punches will designate particular symbols such as numbers, no, and operations. So this is used as the primitive keyboard. Do you follow? Jacquard's loom. Kasi wala pang keyboard, so they're using punch cards through Jacquard's loom. We will discuss that further anyway, no? Any questions so far? Okay. So, and then in 1820, the first mechanical calculator was invented. You must have seen this in an old Chinese restaurant, no? Arithmeter. Let's look for that, no? Which can do addition, multiplication, division, and subtraction. Ito, no? Hindi pa siya adding machine, by the way, no? But there's a version of the arithmeter with a with a crank, no? Okay. So the difference between the step reckoner is that this is a complete calculator. It can do addition, subtraction, multiplication, and division. Okay, let's look at for a mechanical adding machine. Ito, no? This is an improvement of the arithmeter. Instead of using wheels, it uses keyboards, no? With a crank on the right. Do you follow? Keyboards na ang ginagamit. And each key has a symbol designated to represent quantities, particular quantities. Okay? Have you seen this? I've seen this when I was younger. If you have something like this, you keep it because it's a legacy, no? It's an antique. It's a legacy of the past, no? It must be very expensive. It's worth a fortune for sure. Okay? Okay. So by 1820, there was already the patented and manufactured, no? Sa 1820 pala si Thomas E. Colmar, but it was patented and manufactured from 1851 to 1915. Okay. Okay. Do you follow? So 1820. Now the modern period started with in Great Britain, no? During the invention of the differential engine by Charles Babbage. Charles Babbage. The differential engine is not considered to be a computer. Okay. It is only a machine which can tabulate polynomial functions, because when you make calculations, you compute polynomials, right? In engineering, design, you compute. I'm sorry. Tabulate polynomials, and tabulating polynomials can be a very arduous task, laborious process. So what they do is mechanize it using a machine invented by Charles Babbage. It used decimal system and was powered by a cranking handle like a mechanical adding machine. It never came to be used, no? This I realized because the government, which was the sponsor of Charles Babbage, found it to be very expensive. Masyadong expensive, so hindi ginamit. They never manufactured the differential engine. Now later, no, in 1837, okay, Charles Babbage, after having been frustrated with the differential engine, came up with a new design. It's called the Analytical engine, which was the first mechanical general purpose computer. He was recognized as the father of the contemporary computers and considered to be the inventor of the very first working computer. Okay, they follow. We will discuss, no, the contents, or rather the design of the analytical engine. 1837, that was the invention of the first mechanical computer. Now it's only a design. Do you follow? It was never really put into an actual machine. It was developed later in the 1900s. No, during the 1990s, universities in the US were obsessed with Charles Babbage's design. So many of the universities in the US, like Penn State, no, Harvard, they invented, or they put the analytical engine into an actual machine. Okay, so meron silang versions, no? Penn State, I think, no? Produced a working version during the 1990s. Let's look at the analytical engine. Ito. Okay. These are different versions, no? These were not created during Charles Babbage's time. These were created later, no? But this was patterned after the latest, so that latest uh, assembly. It was never built, no, during the time of Charles Babbage, but later, no, okay, these were developed by dif by by different universities in the US. I think Penn State has its version. Pennsylvania State has its version of the analytical engine. Harvard, I think, has its own version of the analytical engine. They did not invent this in order to use it. No, they just want to prove that uh, Charles Babbage design is a working computer. Okay? Do you follow? Hindi naman nila ito ginawa kasi useless. Ang dami ng computers ngayon. No? They just wanted to prove that Charles Babbage invented the very first computer. Okay? Now, in addition to that, no, a follower of Charles Babbage in Great Britain was a Countess Augusta Ada King, a Countess of Lovelace. Where is Lovelace? Lovelace is in England. Somewhere in England, no? Do you follow? He was a follower, avid follower. She was a follower of Charles Babbage. She was also an English mathematician and a binary scientist, chiefly known for her work on Charles Babbage's proposed mechanical general-purpose computer. She recognized that the machine had applications in real life. No, it can be used to solve real-life calculations. In fact, she wrote several algorithms. They were called algorithms during those times. No? Later, they were called computer programs. Okay, intended to be carried out by such a machine. No, do you follow? She wrote the algorithms or the programs to be carried out by the analytical engine. As a result, she is now known as the very first computer programmer. Okay, she is the first known recognized computer programmer because she wrote the programs that are supposed to work on the analytical engine. Do you follow? Are you still there, everyone?
Opo, sir.
Yes,
Okay.
sir.
Okay. So now later in 1884 in the US, no, uh, an invention patterned after the Jacquard's loom was developed. No, it was developed by Herman Hollerith. Now, why is this? No, because the US became independent during the late 1700s, and a few decades after that, no, almost a century after that, people were coming into the US, migrating to the US, and the American government need to make a formal census of its citizens. And then, in order to do that, but the census takes a very long time. So they need to have a recording device. To do a recording device, to use a recording device, they made an invention after Jacquard's loom, okay, by Herman Hollerith, based on punch cards. Okay, it's called punch card tabulating machine, patented in 1884. Okay, uh, Herman Hollerith became the founder of a company called American Tabulating and Computing Company. American Tabulating and Computing Company, ATCC. No? And later it was renamed into IBM, okay, which was the first recognized tech giant. No? His concept dominated the landscape. Became very popular, si Herman Hollerith. Okay? Any questions so far? Now it's time for us to look at the analytical engine. The design of the analytical engine. Ganito yan. Okay. So, the input consists of, when you have a computer program, the input consists of a formula and the data to the formula. Like for example, when you compute the radius of a circle, 3.1415 pi times the circumference of a circle, pi r squared. That's a formula, right? Pi r squared, which means 3.1415 times the radius and times the radius again. No? So it's a formula. The formula is pi r squared. The data is 3.1415 and the value of the radius. Okay? Do you follow? So the input consisting of a formula are provided by a Jacquard's loom. Do you follow? So the first component is a Jacquard's loom. It is used to store the input. So nandun yung program sa Jacquard's loom. Okay? Now, the bad thing about the analytical engine, it's based on the decimal system. No? Yung Kaada Lovelace based on, ang gusto niyang computation is based on binary system. It employed base 10 decimal digits, no? Na nandoon sa punch card. The store, it was called the store, no? So, ang input niya is not a keyboard, but it's a Jacquard loom. Okay? And the second component is called the store. It was called the store, but it's actually formally a memory capable of holding 1,000 numbers of 40 decimal digits. So, ang memory niya, 1K, 1,000 numbers. Which was later known as the memory. Now, the mill, it was then called as the arithmetic unit later. No? Nowadays, if you have the store and the mill together, we will call them the CPU. Okay? Okay? The mill would rely upon its, nandito yun, the mill is the one which processes the formulas. No? It can do operations such as addition, subtraction, and square roots. No? Any questions? Okay. Okay. Now, to understand how it works, let us run an actual program. Okay. Ito yan. No? Galing sa Stanford. No? So there are three basic parts. The mill, the first part. The mill is composed of three wheels. No? Ang wheels will store values. Okay. The first two wheels is called the ingress axis. Ingress axis 1 and ingress axis 2. The third wheel is the egress axis. Ingress stands for input. Egress stands for output. So if you have a formula, formulas are binary, which means they can have two parameters. No? The sum of two numbers, the difference between two numbers. No? So levers ito. These are run-up levers or wheels. Okay? Which can store values. It's like the modern register. No? Ingress axis 1 and ingress axis 2. The output, wala silang monitor, no? So it stores in a wheel. The two inputs are stored in a wheel. The output is stored in a wheel. Okay? Run up lever. These are turning wheels. Okay? So that's, for example, if you have 4 minus 9, 4 is stored in the ingress axis and 9 is stored in the egress axis. No? Do you follow? And ingress axis 2. And the result, which is negative 5, is stored in the egress axis. Now, programs are stored in the Jacquard's loom in the form of punch cards. There are three different kinds of cards. No? First, there's an operation card. A card can indicate whether plus, minus, times, divide, or modulo. Okay, modulo and division are the same, except that the output is the remainder. Okay. There can be combinational and index cards used to perform jumps and loops. No? There's an example later. No? Special cards used to halt the engine para maghinto yung engine or to give a bell to indicate to the operator that it has finished successfully. Okay? Do you follow? Okay. Okay. This session is recorded anyway, no? Then, for example, in a number card, okay, the card can store 10-digit decimal numbers. Okay, ito. Okay. And the variable card is used to store. A variable card can either have an S or an L. It means two operations, no? Store a value, transfer a value from the card from the card's loom into the store or to the memory, and vice versa. Okay, there are special variables cards such that if the store is full, okay, a variable card can be used as temporary storage. Okay, so the operation cards require only 4 holes, no? Plus, minus. Kung ang first hole ang may butas, ibig sabihin plus. Kung second hole ang may butas, ibig sabihin minus, no? Number cards require 50 columns of 10 possible punches. So isang card pala can have 50 columns of 10 possible punches each because there are 10 decimal digits. Okay, so it moves to the left, no? Moves to the left. Horizontal yung kanyang horizontal sequencing, hindi vertical, no? Variable cards can have all 5 possible values, no? Because, okay, representing a number which will be read, no? Una, 5 possible punches representing what should be done, like load or store. And then the next is the number to be loaded or to be stored. Okay. So for example, no, you have N001 means this is a number card. N001 means store a number on location 001. Do you follow? And then an operation card can have either divide, times, plus, x. Plus, minus, no? Dapat minus. Okay. L is an operation card. Okay. L stands for load. L001 is take a value. No? Take a value from the store and transfer it to the ingress axis. Either 1 or 2. The first load will go to the axis 1 and the second load will go to the axis 2. Do you follow? S002 is saved. Okay. This is also an okay. What kind of card is this? Operation card, no? So S002 means store, which means transfer a value from the egress or ingress axis into the store, no? For example, S002 means transfer the value of the egress to location 2. 2 is an address in memory. Any questions so far? Huh? P is print, no? H is halt. CF means this is a combinational card. F tells the card reader to move forward or backward. So pwedeng jump to the next, jump to the previous. So pwede siyang mag-repeat, no? Ang ibig sabihin ng question mark, if the run up lever has been set. The 5 tells the card reader how far to go in case the lever is up. Ibig sabihin ng CF5, go 5 steps further. Okay? Okay? So CF is move forward 5 times. Do you follow? Move forward 5 times. If the run up lever is set, which means it has a value, it's a non-zero value. Do you follow? If the run up, when we say set, the value is not a 0. Reset means it's 0. Okay? When the run up lever has been set, it will move forward 5 times. It's the same as above, but we'll move the run up lever 5 times backwards, no? CF means move forward. CB means move backward. Do you understand? I hope we'll show this in an example, no? Here's a simple example, N001 plus 500 times divided by 30. First, we say N001, 500, which means this puts the 500 into address 001. And N002 plus 30 puts memory address 002 in the store, no? Address 002. And then we have an operation card. This is the card's loom. Divide sets the divide, machine to divide. Okay. And then we'll say L001. So the first quotient, the quotient is loaded into axis 1. The quotient, which is 001, is 500. L002, since L001, this is the first, this goes to axis 1. L002, the second, goes into axis 2, which means that 500 goes into axis 1 and 30 goes into axis 2, and they are divided. When you print, the value in the egress axis is printed right away. No? After the division, the value is the result, which is the quotient, is stored in the egress axis. Okay. S003, store the quotient into address 4. S004, okay, store the remainder into address 4. B means ring the bell to indicate that it's done, and halt, no, indicates, no. We have two examples, no. We have an example of a factorial computation, one which is non-repeating without a loop, and the one which has loops, which has a loop 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Babalik siya doon sa 11. Okay. Let's study this. I have an example, no, in our, no, so we still have time anyway, no. In our Dagler site, I have an example in Excel of a trace of an actual program called the fourth factorial. You can download this, okay? The fourth factorial program of the analytical engine. Let's turn the editing on. Who knows how to compute factorial? What is factorial, anyone? Okay. What is the fourth factorial? Anyone? N factorial? Are you still there? Kindly respond. Everyone, before I proceed now. Okay. So how do you compute the fourth factorial? Anyone? How do you compute? What is the first factorial? So what is the first factorial? So Mabano as an answer. It's correct. The first factorial is 1. That's correct. 1. Why? Because it's 1 times 1. Okay. What is the second factorial? Everyone? What is 2? Yes, that's correct. Why is it 2? Because it's 2 times 1. So the third factorial is 6 because it's 3 times 2 times 1. The fourth factorial is 4 times 3 times 2 times 6 times 1. It's 24. Do you follow? Okay? So, ganun yun. Ibig sabihin ng nth factorial, it's the multiplication of the first n numbers. You can either start from the high number or the low number. Do you follow? So, the fourth factorial is 4 times 2 times, 4 times 3 times 2 times 1. Or it can also be 1 times 2 times 3 times 4. Do you follow? Pareho lang, di ba? Fourth factorial. So, I have there the program for the fourth factorial. You can open this if you like. No? You can download it from where it is in our Dagler class. Okay. Ganito yon, no? This is like, this worksheet like represents like the analytical engine by Charles Babbage. Okay. So there are 3 parts. On column A, you have the Jacquard Sloom. Ito yung kanyang keyboard. They follow a sequence of cards. And columns B to D is the mill. So it has 2 run-up levers. Okay. Ingress access 1, ingress access 2, 3, by the way, and the output lever, which is egress access, axis. Okay. Egress access 1. Okay. And then there's the store. The store is 1,000 hanggang 1,000 ito. Diba? It starts from ST002 and it ends with ST999. 1,000 sila lahat eh. Do you follow? Kasi ganun yung design ng horizontal. Do you follow? This is like the memory. Okay? So ganito yun. The analytical engine will read each command from the Jacquard's loom and process it to the mill accordingly to what command is in the Jacquard's loom. No? Just like a modern computer. So what you have in the Jacquard's loom is the program. Do you follow? So ang program natin nandito sa Jacquard's loom. Okay? And it fetches it one by one. So the first command is N0004. N means set the value of the address 00 to 4. So ang ibig sabihin itong ST00, which is this value, can you find that out? Is the worksheet visible enough? Laking ko na lang, no? Ganito, no? Ibig sabihin yung number 4 is going to be stored at address 0. Ito. Okay? Do you follow? Everyone? And then the second command is N0011, which means the number 1 is stored in the address 001. Dito. Ilalagay niya. And N0021. So ang 1 ilalagay din dito. Now, if you like to know what is the value 4 and the 1 and the 1. The value 4 is our next multiplier. Ba? The next multiplier is 4. The next multiplier is 3. The next multiplier is 2. And the last multiplier is 1. And the value 1 is the decrement, which means how much will we subtract 4 during the next step? 4 minus 1 equals 3. And then after that, 3 minus 1, we will have 2. So this is the standard decrement. Okay. Now, ST002, which is 1 at the first, is actually the first partial product. Okay. The first partial product is 1. The next partial product is 4. The next partial product is 4 times 3, which is 12. The next partial product is 12 times 2, which is 24. And the last partial product is 24 times 1, which is 24. Do you follow? No? So, ganun yung takbo. Partial product yung 002, decrement ito, and this is the next multiplier. Okay? Do you follow? So, this is the first 3 commands. The next command is an operation card, times. So, what will it do? Okay? It will not multiply yet. It will just indicate a multiplication. Now, once the two inputs are there, the multiplication is done. Okay? Any questions? So, first is L002. Being the first, it will use the ingress axis 1. So, anong ilalagay niya sa ingress axis 1? The value from 2. To. Do you follow? Ilagay niya dito. The next is L00. Where will it go? To ingress access 2. Do you follow? So ito, galing sa 00, ilalagay dito. Okay? And then it will do the multiplication and it will store the result to 2. S002. What is the result? 4 times 1 is 4. It will store it to 2. So nandito na ngayon yung 4. Do you follow? Because 4 times 1 is 4. Okay? Any questions so far? Now, the next card is a minus. Okay? What is to be... Questions? Nandiko, do you have a question? Nanditso? Maricon?
Nothing, sir.
Okay. So, let me proceed. Any other questions? Wala, no? The next is a minus. Okay? The next being a minus. What will be subtracted? First, L000. Ibig sabihin yung 4 sa L00, which is currently 4. 4 sa ngayon, di ba? ilalagay sa ingress axis 1. L001. So yung 1, which is currently 1, ilalagay sa ingress axis 2. So what is going to be done is 4 minus 1. It will be stored to L00 because of this. This becomes 3. Okay? So this is a sequence of times and minus, times and minus, times and minus until the multiplier becomes a 1. The next multiplier becomes a 1. Take note, no? So let's just do this. So the next, after the times, we'll have 4 times 3. This becomes 12. And then we will subtract 3 minus 1. It becomes 2. Okay? And then we will multiply. Okay? 2 times 12. This becomes 24. And then we will subtract 2 minus 1 becomes 1. And then we will multiply 124. 1 times 24 becomes 24. Do you follow? So 24 is the final answer. It's the fourth factorial. Do you follow? Any questions? And then we will have a bell. What is the bell? By the way, the bell command is what? B. And H is halt. So we will have a bell here. We'll have an H. Okay. H means halt, which means the Jacquard loom will halt. Okay. Now, this is the non-repeating. Without loop. You know what looping is? Looping is repetition, no? In programming, which means we'll just jump, no? Okay? Kopyahin natin yung programs, no? From the source. No? This without loop. The with loop is this. Tama ba tayo? Yeah, it's correct. Can we copy this at once? Let's try to find out. Okay, need mag-copy na. Love to copy this. Luckily, it was copied. Tama ba ang pagka-copy? Yeah, that's correct. Okay. Gawin na lang natin itong. Okay. Do you follow ito? This is the loop version. Okay. This is the loop version of the of the fourth factorial. The good thing about this loop factorial is if you want to compute the fifth factorial, you just change this number from 4 to 5. Unlike this, no, the without loop, you'll have to extend the program. Okay? Do you follow? Lagyan natin ng bell 4. Okay? Any questions so far? I'll give you assignments on this, okay? I'll give you assignments on this. Okay? We are to finish in 5 minutes. 5 minutes ba? Kasi 10:40. You're supposed to end in 10:50. 10 minutes, okay? Do you have questions? Is it okay if you just finish this? Everyone? Okay. Pangit, no? Pero malaki, we'll just change this to change this to bold. Okay? So, halos pareho lang ito, no? So, when we say this will have 4, okay? And then, zeros, this will have 1, and this will have 2. So, times L001, so this will become 1. Okay. L00, this becomes 4. Okay. S001, S001, so 4 times 1, this becomes 4. That's the first partial product. Bakit 001? It should be S002. Let's look at that in the without loop. S002 dito eh. Anyway, no? Anyway, it's a different version, so you just have to make do, no? So dito ilalagay yung times sa S001. And then we'll minus 000, which is 4. Okay, 002. Mali, no? 1 ito, I'm sorry, no? Kasi 1 ito dapat. Binaligtad na niya ngayon yung ano, binaligtad na niya yung gamit ng 00 at saka 001 saka 002. But it's okay, no? Programmers will always do that, no? Paminsan baligtad rin. Okay? But it's okay, no? Pwede mo baligtad rin yung variables. It's still the same thing. Okay, kasi ito eh, binaligtad niya yung it inverted the use of 001. The previous 001 is now 002. Okay? So L00 is 4 and 002 is 1. So this is now the decrement. And then we minus, we store it in 00. So this now becomes 3. Do you follow? Everyone? 3. Okay. Okay. Then we have L002, which is L002 is, how much is 002? So, okay. Ulitin na lang natin. Can you still see? I hope you can, no? L002. So when we say L002, we will load ingress access 1 with the value from 2. The value from 2 is 1. And then egress access 2 is 00. The value is 3. 3. So set CB 11, which means it will move back 11 if the value is set, which means it's not 0. Okay? So I think it will check both, no? Ingress access 1 and ingress, it's not 0. Okay? It's still a minus. Kasi minus pa dito eh, di ba? Dapat meron tayo dito. Egress access 2 is 4. Okay. Dito, egress access is 3. You follow? Do we have that here? Hindi natin nalagay, no? Times. Ang egress access dito is 4. Okay? The egress access is 3. The egress access is 12. The egress access is 3. I'm going to upload this again, no? The egress access is 24. Okay, the egress access here is 1. 2 minus 1, 1. Pag dito yung 1. Okay? I'm going to upload this again, okay? So yung with loop ito, okay? So it's still a minus, no? 1 minus 3. Dapat baligtarin ito. Sige lang. It's not, it's a set. 1 minus 3, the egress axis is negative 2. Okay. So CB 11, which means we'll go back 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hanggang dito. Okay. Dito. So we'll transfer this para hindi tayo mahirapan. So anyway, we're running out of time, no? So we'll just continue with this next meeting. Any questions so far? Okay. I will give you your first assignment next meeting. Everyone?
Sir, my question po, sir.
Yes, what's the question?
Po namin pwede access yung recording po.
Come again? Can you write it on the chat? Can you write it on the chat? By the way, no, there's a question from Andre Vincent. What does ingress? Ingress means input. Egress means output. Do you follow? So in a formula, the inputs are in the ingress and the output, the result is in egress. Am I clear? Vincent? Ang mga input sa formula, ibig sabihin nito, 4 times 1. So the input is 4 and 1. 4 times 1 equals 4. So the result is in egress. Okay? Thanks for the question, okay? Ito kasi yung first pass. Any questions? Okay. Saan po ma-access ang recording? In the regular site. No? Dito, no? Sa ating regular site. Katulad last meeting, may ito, lalagyan ko ng Zoom meeting. Do you follow? And this is 4-301. In your case, it will be 4-100. Okay. Kirby Kent, Asombrado. It will depend on the sequence of the L and the address. No? For example, here, when you say L001, when you say, for example, this is L00, saan ilo-load yung 00? Dito sa ingress axis 1 because this is the first L after the minus. Itong L002 dito ilagay sa ingress axis 2 because this is the second L. And where is this taken from here, no? Ang value ng ST002 kasi L002. Okay? Nicole?
Yes, sir. Get, sir.
Okay.
Thank you.
Okay. Any other questions? You will have an assignment now. This will be part of the first formative test. So you'll have to familiarize how to program. We'll be programming another computer later, no? Which is called IAS. We'll also try to program the other computers like IBM and PDP computers. Okay. Any questions so far? So see you next meeting, everyone. Okay, I'll upload the session.
Okay, sir. Thank you, sir.
Thank you.
Thank you po.
Thank you, sir. Goodbye.
Thank you, sir.
Thank
Thank
you,
you po.
sir.
Good day po.
Bye.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.